discuss regarding the AC voltage regulator. So what do you mean by an AC voltage regulator? An AC voltage regulator is a circuit which converts a fixed AC into a variable AC. So fixed AC, why do we have to convert a fixed AC into a variable AC? Because we need a controlled output. In some applications like domestic or the industrial heating, or to control the speed of the DC motor, or to control the induction motor, we use this AC voltage regulator. So here the AC voltage regulators are classified into two types. One is of the single phase and the other one is the three phase. Now let's discuss the single phase AC voltage regulator. In this circuit, we can find two thyristors. These connected back to back. Two thyristors which are connected back to back to convert a fixed AC into a variable AC. So here it is of the R load. Discussing regarding the R load. So a source, an AC source is connected to two thyristors anti-parallelly, and then it is given to the R load. Let's see the working of this circuit. When the positive half cycle is applied to the circuit, so it takes the current will flow from the phase T1, R load and the neutral. So which we can observe here in the waveform. So this is the input given, the sinusoid input. So for which when the T1 is triggered alpha, it will start conducting from alpha to pi. At pi, due to the natural commutation, the T1 will be turned off. So from again at pi plus alpha, the T2 will start conducting. T2 starts conducting in the reverse direction. So if you observe, when the negative cycle is applied to the circuit, the current will start flowing in the reverse direction. So this is the reverse direction. It is flowing from load to the source, not from source to the load. The first previous condition, when the positive is applied, the current has flown from the source to the load. This is technically as the I1 and this is as the I2. So I1 is from source to the load and I2 is from load to the source. So in the second condition, that is the negative cycle is applied. So T2, we can get the controlled output voltage in the negative direction. So if we calculate the output voltage, the V0 is given by 1 by pi integral alpha to pi Vm sin omega t dt. We saw this. So Vm by pi integral alpha to pi sin omega t dt. So we will get Vm by pi into 1 minus cos omega t alpha to pi. So if we solve this one, we get Vm by pi into 1 plus cos alpha. So this is the output voltage which will be delivered across the load. And if you want the I0 is equals to V0 by R. So V0 is nothing but Vm by pi into 1 plus cos alpha by R. So pi into R. So this is all about an AC voltage regulator. Let's discuss regarding the choppers. So what is a chopper? A chopper is a static device which converts a fixed DC into a controlled DC. So to convert a fixed DC into a controlled DC, we need a device which is nothing but a chopper which acts as a static switch. So if you enclose a switch in a box, it forms a chopper. So it depends on the T on and T off, the time periods or the pulse width of the waveform. So here we use as a switch either LCR or IGBT such that we get a controlled DC. So the choppers are classified into, the basic classification is two types. One is a AC link chopper, the other one is a DC chopper. So AC link chopper is a chopper which converts a fixed DC into controlled DC in two stages. So first one, the fixed DC is given to an inverter where it converts a fixed DC into a pulsating AC or a controlled AC. This controlled AC is given to a transformer where we can step down or step up based on the applications, and that is given to a rectifier. So the rectifier converts this pulsating AC into a pulsating DC. So when we observe this circuit, here we can find two stage conversions from DC to AC, bulky, the cost is also not affected. So hence, we have got one more type, that is a DC chopper. So DC chopper, where we directly use a chopper device which converts a fixed DC into a controlled DC. These choppers again are classified. DC choppers are again classified into step up or step down. Step up is also known as boost chopper, boost converter, and the step down is known as buck converter. And the combination also we are having, that is the buck boost converter. So these choppers are used mainly in the chronicles, speed control of the DC motors, traction motors, battery operated vehicles. So in the next class we will be learning about the basic operation of a DC chopper and the step up, step down and the buck boost choppers.